In this video, we'll be talking about river and boat. We have a question here, and the question is saying a motorboat heads due east at 16 meters per second across a river. That's kind of what we're seeing right here. This boat is moving eastwards across the river at the pace of 16.0 meters per second. However, we also have a river that's flowing due north. So there's some sort of current that this river is generating that's pushing northwards at a rate of 1.50 meters per second. The question is asking, what is the resultant velocity of the boat? Well, the first thing we need to do is illustrate at least, draw and illustrate the question itself so you have a better sense of what's going on. So that's what I did here. Here's the river. The boat's traveling eastwards at this pace, and then the river is flowing north at that pace right here. You'll notice that as the boat is trying to cross the river, the current of the water does push the boat a little bit northwards, so it does take this type of path, if you will. Let me just show you that to you really quick. So the boat starts here, but because the river is pushing a little bit northwards, it does take this route. Not only is it going in this direction, it's also making the boat travel slightly a little bit faster. Because the 1.50 meters per second is adding on to the existing speed that the boat is actually traveling in. So we do see the boat traveling a little bit faster than its usual speed of 16.0 meters per second. So the question is asking for the resultant velocity. So we're asked to solve for the velocity of the boat. Keep in mind that velocity is a vector quantity. And when we're talking about vector quantities, we're talking about quantities that express both the magnitude and direction. So vector quantities talk about magnitude and direction. So not only do we have to say how fast it's going, we also need to kind of point out exactly where it's going. And so to do that, the first thing we're going to do is we're going to sort of replicate this this part of the drawing on a blank space. So I'm going to draw that here. So we have a sailboat traveling 16 meters per second to the east. So that's what this vector is. So here's your 16 meters per second due east. And of course you have the water current that's pushing due north. So that's what this is right here. Okay, and then keep in mind that the current of the water is moving at a pace of 1.50 meters per second, whereas the speed that the boat is traveling due east is 16.0 meters per second. And we notice that the boat is moving in this direction. It's going this way. And the question is asking how fast is it going and what direction is it going at. So let's go ahead and find the magnitude first of this vector quantity. So we're basically asked to solve for this side. Now you notice that this basically is a shape of a right triangle. And I call this a right triangle because there's a 90-degree angle between these two sides right there. And because we're dealing with a right triangle and we know two of the three sides of the right triangle, we can actually use an equation known as the Pythagorean theorem. So let me go ahead and write that here. The Pythagorean theorem. And basically the Pythagorean theorem is simply put as a squared plus b squared equals c squared. And so we can use that equation to solve for this third side, which is actually what our velocity is right here. So keep in mind that c squared is in reference to the hypotenuse. So C is the hypotenuse. A and B could be any one of these two sides here. So we could use, I could make this one my A, and then I'll make this one my B. And then all I have to do is just solve for C's. All we have to do is solve for C. So our equation is set up the way we want it. So we're just going to go ahead and plug in our values. So C squared equals A, which is 16.0 squared, plus B squared, which is 1.50 squared, and that gives you the resultant, which would be C squared. So let me just go ahead and punch in the data. Keep in mind that you do have to square the values because that's what the equation says. So this one turns out to be 256. This one turns out to be 2.25. That equals C squared, and then we're just going to add these two numbers up together. So our C squared is 258.25. And because C is squared, we need to get rid of this squared symbol by taking the square root. So the square root of all of that gives us a value of 16.07. I'm going to say 16.1. So our resultant velocity is 16.1 meters per second. That's just the magnitude part. So that's actually how fast it's going as it takes this route here. Okay, so I'm just going to plug in that value in there really quick. So 16.1 meters per second. This is our magnitude. Let's go ahead and look for our direction. So our direction is asking, is it going east, northeast, southwest, so on and so forth. But not only that, it's a little bit more specific. We also want to know exactly the degree angle that it's veering off from its original intended path. You notice that it was supposed to go this way, but because of the water current pushing it northwards, it does veer it off by some amount, which we do need to find out exactly what that is. And so we're asked to solve for theta, and then not only that, we need to also explain that is it going north, is it going northeast, is it going south, so on and so forth. So let's find our theta really quick. All right. Now we know all three sides of the triangle. We also might need to know the names of the three sides because, since we're dealing with theta now, we need to look at trigonometry functions. So the C, that's your hypotenuse. Just use a different color. That's your hypotenuse. The 1.50, that's your opposite because your opposite is the side that's opposite of the angle. And then the 16.0 meters per second side that's touching the angle, we'll call that one the adjacent. And if you know your trigonometry mnemonic, we're going to use SOHCAHTOA. Now, we can actually use any one of the three to solve for our theta. So use any one of them, and just as long as you know how to plug in the equation, you should still get the same answer in the end. So I'm going to use TOA, since I know my opposite and my adjacent. And TOA is signified as tangent theta equals opposite over adjacent. And just keep in mind, your first letter represents the trigonometry function with the angle. The second letter represents the numerator. And the third letter represents the denominator. Okay. Let's go ahead and plug in our values. So tangent of theta equals opposite, which is 1.50, over adjacent, which is 16.0. When we divide those two, our tangent theta should be 0.09375. Now that is not our final answer because we do have to eliminate the tangent in order to get theta by itself. So by doing that, we need to take the inverse tangent. So that would be something like this. And you take the inverse tangent. On your calculator, if you have a graphing calculator, the way that you should do that is punch in the following numbers or the following buttons. First button you should hit, it should be sine. Second button you should hit should be whatever the trigonometry function you're using. In this case, I'm using tangent. And then it's going to ask you to plug in the number. So just plug in the number and then just hit the enter button at the end. Okay? That's the sequence of buttons that you have to hit. All right, so I'm going to do that right now. So the inverse tangent of 0.09375 gives me an answer of 5.355. I'm going to say roughly about 5.4 degrees, and so that is my angle. And so that's going to be this thing right here. So my theta is 5.4 degrees. Now we also need to point out exactly where it's going. Now you notice that it's going to the east. It's moving eastwards. But it is also moving northwards as well. So the direction is northeast, but we need to be a little bit more specific. It's either going to be explained as north of east or east of north. And the only way we can be able to figure out which one of these two it would be is ask yourself, where is this angle touching? Is it touching the north vector or the east vector? You'll notice that the north vector is actually going right like this, and the east vector is going this way. The angle is actually touching the east vector. So wherever your angle touches, that has to be the direction of the second part of that word phrase. Okay? So north of east is referring to an angle that is touching the east vector right here, whereas east of north represents an angle that's touching the north vector, which looks something like this. Let me just draw it in a different color. If we're looking at this angle instead, you'll notice that this angle is touching the north vector, and so we can actually say east of north in that situation. But that's not what we're seeing here in our question. Our question is actually showing us the angle touching the east vector, and so we're going to be using the word phrase north of east. Okay? And if you think about it, it's actually going northerly from the easterly intended direction. So the easterly direction is our point of reference, but the boat's actually being veered north of the easterly direction, if that makes sense. And so our actual final direction value would be something like this: 5.4 degrees north of east. And so our final velocity would be 16, let me use a highlighter actually. Our final velocity will be 16.1 meters per second, 5.4 degrees north of east.